Hello, sir. Sir, can you solve question number one of assignment number four?
Sorry, yeah, Nikhil, tell me.
Yes, sir. Question number one of assignment number four का question number one.
Uh,
Tell me.
so I'm not aware of the questions that you're having in assignment at this moment. What is it related to?
Digital circuit. Based on digital circuit expression.
Yeah, what expression?
Oh, sir, digital circuit is given
Yeah, I think we are having class for
based
digital
on gate.
circuits itself. You can type in that question. We'll see if we can include that. Because
Okay,
this week
okay.
I have prepared some questions based on K-Map minimization. So last week also we solved some questions based on K-Map minimization. But there were some brief topics that were to be covered and were not completely done in last week in the questions that I solved. So right off the bat, some of them were related to this year product of sum. So in that you have to be careful where to take 0 and where to take 1 while solving these questions. And apart from that, I hadn't covered the don't care situations or don't care conditions that you might encounter in K-map. So I intend to solve some questions based on those topics in this session. And meanwhile, like Niketan asked, you can just type in that question. We will just see if we can quickly solve it, or else I can include it in next session. So it's already 3:05. I think we can start. So yeah, welcome to this live session 4 of digital circuits. And this session is having some questions and problems based on K-map minimization. And as you are aware, your professor is Professor Shantanu Chattopadhyay, and I am Utpresh. So earlier, these highlighted portions were covered, and this week I am again going to solve some questions based on K-maps. So, why do we use K-map minimization? So that is pretty clear for now, and we have solved some problems also, and also seen that there are some forms in which you can define or express your function. So there might be canonical form, or there might be your functional form, or even you can use your K-map denotion that is synonymous with your truth tables, and you can use that method to minimize your functions. And minimizations, as we know, we do because we need to implement these functions in our digital circuits using gates. So if you minimize the function, then your number of gate that are required to realize this function would decrease. So your digital circuits become less and less complex as you minimize the functions. So K-map is a very good method as you have some rules that you have to follow while solving for these problems. And you don't need to by heart remember the properties that we had seen earlier while minimizing the functions directly. So this is convenient till you are solving problem till 4 or 5 variable, and after that it is still easy, but you have to write a lot. So just just to know, just to keep in mind, till 4 or 4, 5, 6 variables, K-map is okay, and it's pretty easy to follow what you're doing. Something that you might encounter in K-map is known as don't care conditions. So let's say you have a K-map. Just for an example, we have just a two variable K-map. So suppose you have a one here and a don't care condition here, let's say. So this don't care condition might arise because of various reasons, and that is denoted by X in this either in truth table or in K-map. So this X might be having a value either 0 or 1, and that you have to decide while minimizing. So whatever value will help to get your function to its minimized state, you have to take that as the value of x while solving for don't care conditions. So here in this case, let's see if we take x equal to 0. If you take it to be 0, then what you have, this function that would be a bar b bar out of this k map. And if you take x to be 1, since it is a don't care, so it can be either 0 or 1. So in that case, this will form a implicant that is formed out of these pair of ones, and that will give you a function to be a bar. So here you can clearly see right off the bat that is number of gates that are required to realize this function while having a favorable case for don't care condition is drastically reduced. So you just need an inverter here in this case. But in this case, when you take x to be 0, there bigger expression is there. So you need to build a different circuit for that. So don't care condition, you have to take a value of that expression, which will help you to minimize it to a value where the minimal hardware is required. So value of x does not alter the outcome. So you don't. So that's why it's called a don't care condition. And the reason it might come up, it may be because if this is your don't care condition that is given by a bar b in this case in our this truth table. Now this may be an output from a previous block of circuit that can be anything. So just for an example, if you are having something that gives an output either 0 or 1 based on some comparison, let's say it compares a value x with 8. So if x is less than 8, it might give 0 until x equals till x 12. So from 8 to 12, it might give a value 1. But let's say its output can span till 16. So whatever value is coming from 12 to 16, that might be a don't care condition. So this is just an example. This previous block you would not know, but you just know that this shows up as an X in your truth table or K-map. So you just need to take a value that will just help your case. So how do we denote these don't care conditions in our functions? Is shown by this. So if you need to write the don't care conditions, then Itha has posted a question in chat box. The number of midterms after minimizing the following Boolean expression is. Is this a problem from your assignment or something? Niketan, why are you sharing your screen? Please don't share the screen if you don't want to show something. Yeah, so this is from assignment. Okay, we will see. Niketan, is this the same question or something different? So Niketan is also asking to solve a question from assignment.
My question is question number one.
As I told you, I'm not aware of the assignment sheet that you guys are getting. So just type in the chat box.
Sir,
So
based on the circuit है, so
yeah,
that
it might be based
I
on
am not able to type.
okay, okay. So you can just draw and post a screenshot if you want. So yeah, as we were discussing the don't care conditions, so in the functional form, the don't care conditions are given by this form. So this is the usual function that we had seen till now. So whatever K-map you might be having, that its terms will be given in this form, and the don't care condition will be denoted by D and in bracket whatever are the places for the don't care condition. And in actual form, K-Map is actually an upgraded version of Venn diagram. So I hope you guys are aware with Venn diagram. So just for a short example, so let's say this block is A, this is B. So whatever is included in its common form, that would be A bar, B bar. This whole will be the universal set. So whatever is outside this, oh, sorry. Yeah, so whatever is outside these two circles, that will be A bar, B bar. Whatever is in this A circle, that would be A. Whatever is in this B circle would be B. And exclusive of this area, then you can say that this will be A bar B, just this region. And synonymously, this will be A B bar. And this is just a way to draw how your function is forming. And K-map is just a simpler way to denote these things. So you can imagine if you are having a more number of variables, you might have to just keep adding on the circles and be careful of the overlaps. So K-map is a pretty good generalization of this Venn diagram denotion as well. So in this case, it is pretty neat, and you have defined regions, and you can just denote which region you want to point out to. So yeah, K-map, as we are aware, since you are following your numbers and operations in binary form, in binary number systems, so as your number of variables increase, that number of terms in your K-map scaled in form of 2 to the power n. So a 5 variable K-map will be having 32 terms, whereas a 6 variable will be having 64. So this is just to give an idea that this how you would have to have a more number of tables, or you will have to take care of more number of variables as you scale to higher number of variables. So that's why till 5 to 6 variable it is pretty okay to solve with K-map, and nobody would ask you more than that. And also there is something known as implicants in K-map. So implicants is, suppose you are having a K-map and there are some terms, let's say. So this is 0, 1, 0. So you might be having some function defined in which your ones will be lying around on this K-map. So here, whatever groups that you can make, so those groups are known as implicants. So here, as you can see, since K-map is rollable, this forms a pair with this. So this will be one implicant. Again, this can be rolled. This will be your second implicant, and you have to cover this as well. So this will be a third implicant. So whatever these groups you can make, so that are known as implicants, and that depends on what form you are making these groups. So a function might be having different forms based on your choice of groups. So there are some terms that you should be aware of. So implicants are whatever are the maximum numbers, or whatever are the number of ones that are in your K-map, or zeros in form of POS. So those are implicants. Then comes prime implicants. So prime implicants are the minimum number of largest groups that are covering your all ones or zeros. Those will be prime implicants. Then comes something known as redundant implicants, and then there is something known as selective implicants. So the reason you might be having different solution to a K-map is actually this selective implicants. So just for a short example, if you are having a K-map that is having this form, So here you can form your group like this with this, and this will cover everything, but you can have this third group also. So as I told you, this number of implicants here, you can form these three groups. So implicants will be three, but here as you can see, this one is redundant. So these one are actually covered in some other bigger groups. So this is not necessary. So this will be one redundant group. And also I missed one, that is essential implicants. So what is essential implicant is there might be some grouping in your K-map in which there is some one that is not covered in any other group. So this we will see in one of the example questions that we are going to solve today, that how essential implicant might be different from these other defined implicants. So let's start with minimization of this function that is given by f a b c d e. So mind this, that this is a five variable K-map problem. Here
Hello,
the
sir.
function,
Excuse me.
yeah, Komal.
Sir, back to your previous slide. Can you explain the all things with example? For example, you have like shown for first one, no? For prime, for essential, for all things.
With
Just give the
respect to
number.
POS.
But no, no, anything.
Can you
POS
just
or
repeat your question?
SOP? Yeah, I mean, this implicants,
Hmm.
prime implicants, redundant, selective, essential.
Okay.
These are all things with example.
Okay, yeah.
Means you have
So,
given example for first, no? So for
hmm.
remaining also just explain with example.
Yeah, so we have a problem for that. Do you want me to directly solve with that? We can directly
Mm,
start with that also.
yeah, okay, no problem.
So, yeah, actually there is this problem that I've included in this slide. So you have to find the number of implicants, prime implicants, essential prime implicants, redundant prime implicants, and selective prime implicants for this function. Uh, I just forgot to write the number of variables. So since this is going till 10, we can solve for four variables. Yeah, for if we are having this kind of K-map, here we can try to find out the number of implicants and respective implicants that we can try to find out. So I will just write the table. So since this is a four variable function, we will be having 16 blocks. This topic has been covered by professor in the course, or I'm not completely following. I'm just trying to be in line with what prof is teaching. So here I will just write out the location of the ones that we are having. So 0, 1, 5, 7, 15, 14, and 10. I will just use a different color. Yeah, so these are this is the K map that we have for this problem. Now here we can see that every one that you have written qualifies as an implicant. So either this one or a group of ones. So since this is just implicant, this has no condition over it whether it can be prime, essential, or redundant or anything. So just these ones qualifies as implicant. So the number of implicants here we can simply count and see that these are 1, 2, 3, 4, 5, 6, and 7. So in total there are 7 implicants. So if you just plainly and blatantly try to write down this function, like if you just try to write down every term, I won't write every term, but for this one you can just write down this and so on. So for every one, these qualify as implicant. But for prime implicant, you have to form the largest group of ones possible for your K-map. So here in this situation, as you can see, the largest group of ones that you can form is a pair here. So you can just mark out the pairs which will cover all the ones. So I'm able to form 1, 2, 3, and 4 pairs here. But again, prime implicants is something that all possible combinations in your K-map. So in accordance to the formation of pairs, here the number of prime implicants will be, I believe it is 6. 1, 2, 3, 4, and vertical ones 5, 6. So here the prime implicants become 6. But again, as we had seen in the earlier example, where we have seen that several ones might be covered in multiple number of groups. So those become a redundant prime implicant instead of essential one. So here, as we can see, I will just label these groups. Again, let's see if we have another color. So these horizontal ones I am first writing down as 1, 2, 3, then vertical ones. Is this blue and blue visible? I hope. Then 4, 5, and this 6. So I hope these labels are visible. So here the horizontal ones are essentially covering these first three horizontals, 1, 2, 3, and this one vertical 6. That is actually covering all of the implicants that are possible in our K-map. But again, as the definition of essential prime implicants go, these are the implicants or groups that cover the ones which are not covered by any other group in this K-map. So here in our K-map, we can clearly see the group 1, which is covering this one, and the group 6, which is covering this last one, that is at 0 and 10. These are not being covered in any other of the implicant that you have formed here in the pairs. So these qualify as essential prime implicants or essential implicants. That is synonymous. Now comes redundant and selective. So redundant as by definition and whatever we saw earlier. So whatever are the ones that are covered in multiple groups, those will become redundant implicants. And in this case, if we just take the horizontal ones that are 1, 2, 3, and the number 6. So these actually cover all of the conditions. But the vertical ones that are 4 and 5, these are just covering these ones again and again because those are already covered in some other group. So they become the redundant implicants. So here the number of redundant implicants become 2, and selective implicants here, just a direct formula you can use here too, that number of prime implicants minus essential implicants would be your selective implicants. So selective implicants, you have to choose which one you want to use to denote your function. So that will directly give 4, or else as we have just counted, you can take 1, 2, 3, these three horizontal ones, and the number 6 as vertical ones, and this will define your whole function. So these 4 you can select, or else you can start with the vertical ones. So there you can take 6, 5, and 4, and then take one horizontal one, that is number 1 group. That will form selective implicants. So you have a total of 4 selective implicants to make your function. So this problem just denotes this is one of the reason why you might have multiple solutions for your K-map. So redundant prime implicants, Gaurav.
Sir, can you please repeat redundant implicants?
Yeah. So Gaurav has also asked the same thing. I will again go through this. I hope this labeling is clear to you guys.
Yes, sir.
Okay.
Sir, essential and redundant quite similar.
Sorry, your voice is getting cut.
Redundant and essential quite similar.
Yeah, let me make that clear. So I will include redundant and essential to explain again. So by definition, if you want to denote an implicant as an essential implicant, you have to be sure that whatever group you are choosing, group of the choice of group that you are selecting for essential, that should have a 1 that is not denoted in any other group. So in this whole K map that is being drawn here, you can see that the ones that are at 0 and 10, these are not covered in any other pairs that we have drawn. So here you can see the all other ones excluding 0 and 10, those are being covered by some pair or other. So these horizontal ones 2, 3, and 4, 5. These actually cover these four ones at least once. So these four, actually these five are actually covered by at least one pair, but these 0 and 10, these are not covered in any other pair. So these become essential, and essential implicants are the ones that will be definitely in your solution. So if you try to minimize this K-map in one way or another, if you choose any group, but finally these essential will be an inclusion in your solution. So essential will always show up in your solutions. Now, whereas, let me discuss about redundant. So just leave this one. We'll draw a simpler one. So the one which we draw earlier. So if you have a three variable K-map, let's say here, if I'm to minimize this function, what is the way to go? So that you will have to leave the variables out for now. You will have to make pairs of ones, right? So I can make these two pairs and cover all the ones, right? Here the function is already minimized and its minimum form. But if you want to just group everything, like I am choosing pairs to draw here, so this pair is actually redundant. And why this is redundant? Because the ones that I have chosen to pair, they are already a part of groups 1 and 3. So even if I write this down, this will be just redundant, and in your final function, this will be definitely reduced and this won't be a part of your final solution. I hope you got what is redundant implicant. So Gaurav, Diksha and Komal last.
Clear.
Yeah,
Clear,
yeah,
clear.
nice. Okay. So these are some of the questions. So I will be just frank with you guys. So these short kind of questions will be can be directly asked in exam like GATE or some other entrance exam. So this doesn't hold that much value in your like exam in semesters or something. But since this is a short problem in your digital circuits course, and this can be asked anywhere, so you just need to know the definitions. So just try to remember what is prime implicant, what is essential implicant, what is redundant, and what is selective. So that's why I've included this question. Uh, Somebody asked in chat. So Itha, Pratyusha, whatever you asked, I have just noted it down. I will see whether we can solve this in this session, or else I will get back to you. So you guys have my mail ID, I guess, so you can also ping me there. I will solve this for you if I'm allowed to. So let us solve this five variable K map, and this is having a don't care condition. So you guys have solved good number of problems on don't care, or should we go through this problem?
Sir, please solve this. Actually, that one is five variable, na?
Yeah, this one is five variable, so a bit
So
tedious to write, but I guess you guys have solved some problems in don't care condition. Yeah,
no,
anyways, I will
actually,
solve it.
sir, I want actually solution for the five variable.
Five variable, okay, fine. So we are accustomed to, so I will start solving this. Meanwhile, you people can also try to solve this. Just use your pen and paper, and since this is a written problem, you can always click a pic and post in chat box. So this is a five variable problem. So here you just need to be aware what K-map you are drawing. So since in a K-map you can have at most four variables to be denoted properly. Uh, so I will just use this form. So this table will be for a equal to 0,
Yes.
and this will be for a equal to 1. Meanwhile, B, C and D, E will go in rows and columns. And this we can fill up in the usual way, keeping in mind that your A is 0 here in this table and your A is 1 in this table. Okay, and the usual places. I hope I don't have to write down these labels. This counting is pretty simple. So this starts with 0, 1, and 2. Okay, this is not visible. Fine. Yeah, so you can quickly write that down also. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. So this is just a quick way to write this down, or else you can always refer to the position of the column that the box is denoting. Continuing from 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, and 31. So this is just a quick way to write this down. And we have a function, so I will just write down the ones that are given in the function. So these are at position 1, 5, 6, 11, 12, 13, 14. Okay, so actually the function is not having the use of the fifth variable, but that is okay. I will just, after solving this problem, I will tell you if you are having some other pair formation between these two tables, how will you go about that? And we have two don't care conditions, that is D, 3 and 4. So at 3, you have an X, and at 4, yeah, Hima, tell me. Hello? Okay, fine. Let it be. So, currently we don't have a use for this one, but we will come back to this table and we will just add some numbers here to see how to solve a five variable problem. So here when you have this K-map for a equal to 0, we have to ensure that you are having always you are having a prime implicant, you have to start with a bigger group. So here if you are able to form a group of 8, you have to mark that out. So here in this situation and the don't care conditions you have to take according to the formation of group. So if the don't care condition is helping to form you either a group of 8, 4 or 2, by taking it 1 or 0, you have to take its value accordingly. So here in our case, the x, if we take this x to be 1, which is at 4, this will help us to form a group of 4. So this we can take as 1. Similarly, since this x we have already taken 1 and this is a don't care condition and K-map is a rollable form, so this will form a second group. And in this condition where the ones at 1 and 11 are left out and just one don't care is at 3. Here, if you take 3 to be 0, then you have to write down two big implicants for 1 and 11. So instead, we can take the x to be 1 so that we can form these two pairs. So 1 and 3, and this 11 and 3. So we first aim for the bigger group and we form the group of fours. And when the group of four is not possible for remaining implicants, we try to form pairs. And even if you are having some another one left out somewhere where it is not being able to form a pair, then and then only we will take it to be an independent implicant. Or I'll just try to form a pair. So if we try to write this down, and I hope from last time and also from the course you remember that whatever variable is changing, you have to leave that out, and whatever variable is constant, you have to take that in your implicant. So this group of 4 that we first formed, that is comprised of 4, 5, 12, and 13 positions, that is having variable c that is not changing. And if we see at the top, d bar is not changing. So cd bar, and since this is from the table a is equal to 0, so a bar will be added here. So a bar is of course not changing because here you don't have anything correspondingly to in the second table where a should be 1. Then we will see the second quad that we formed. The second quad is this rolled one that we formed, that is 4, 12, 6 and 14. So this second group here, again C is not changing and A is not changing of course. So A bar and C bar will come. And if you see at top, you have one column 1 0 and other column 0 0. So here E bar is not changing and D is changing from 1 to 0 if you start from this end. So here you will get E bar in this. And now we have two pairs remaining that we can directly write down in similar fashion. A bar will be there. So I'm trying to write down this top pair that is having B bar and C bar that is not changing, whereas here D is changing. So E remains. And the last pair that is found with this don't care and this 1 at 11. In that case, A is not changing and D and E itself are not changing. So those are not actually bar, D and E. And here from among B and C, your C is not changing. So it will be C bar. So Gaurav is saying A bar, C.
Sir, in second term, C is
Yeah, yeah,
not
yeah.
changing. I mean, not
Yeah, I
C
think
bar.
so that it's C. Yeah, thanks for the correction. Yeah, so that will be this. So this will be the final form of the minimization that you will get when you consider your don't cares to be having a favorable case. Now, since somebody asked that how to solve when you are having a five variable problem, and in our the specific case, there was nothing in the countings where a got to be 1. So let's add some don't care conditions and try to change this problem for our understanding. So let's say you have some more don't cares at 17 and 19. So if you add don't cares at 17 and 19, you will be having a pair of don't cares at this position. And if you just try to move this table that is a equal to 1 and overlap it on a equal to 0, you will see that positions 1, 3 overlap with 17 and 19. Now what that means, at position 1 and 3, you are having a equal to 0, and at position 7 and 19, you have a equal to 1. So here actually a is changing. And also when you overlap it, and K-map is rollable, so that does not only apply to row and column, but when you place this K-map for a equal to 1 over a equal to 0, you can actually form a quad. So this quad we can denote using this orange color. So this and this 1x, they will form a quad. So if you have this kind of don't care, so in that case, if you try to write down the solution, you will have these first two usual quads, A bar, C, E bar. But now when we had this one pair at the top with 1 and x, that is now actually forming a quad with these two don't cares that are at a equal to 1. So you can form a quad there. Now there the value of a changes. So in this expression a won't come because a is changing its form from 0 to 1. So you will have to leave a out, and then there b and c are not changing their value. They are remaining to be 0 0, and among from d and e is not changing its value. So there we can exclude A, we can write down B bar, C bar, and E has to be included. So this quad forms if you are having this five variable problem and these two don't cares are included that are at 17 and 19. And the last pair that is still a pair with this that will remain the same. So what changes when you go from four variable to five variable is that you have to take care of these two tables now. And you have to be aware whether this table is rolling and forming a bigger pair or a quad or a group of 8 or not. Even here a group of 16 is possible. So whatever is in powers of 2. So I hope the five variable K-map is understood. Whoever asked the question.
Yes, sir. Yes, sir.
Yes, Sanjay.
Sir, what if in function we have 20, 21, 23, then how to solve?
You were saying the ones and not don't cares, right?
Yeah, in don't care also, but in our function also, if there is 20, 21 or 28, like, so how it get merged
Okay.
together?
So let's add some functions. So let's say we have at 21, 23, 24. Okay, let's for example take this. So we will write down these ones at 21, 23, and 24. So where did 21 go? Yeah, this is 21, 23, and 24. So you are having these ones now. Okay. So while solving, so as we had seen, when we had a case where a equal to 1 was not having any variables or any ones in it, so we just individually treated that to be a four variable problem, where a was not changing its value, but the values were being changed in B, C, and D, E. So similarly, here when we have this kind of ones, let's say we have added these ones, and we are trying to make pairs out of it, pairs, quads, and group of 8s and 16s. So in this case, first, you have to see if you overlap these two tables over each other, whether a big group forms or not. So, in our case, a group of 4 can be formed between 17, 21, 1, and 5 if you just overlap the table, or else, even in this table itself, a equal to 1, these form a quad. So, whatever you are able to locate first, and that should cover all the ones, and if the don't cares are helping, that is well and fine. So, either you can use this quad or you can, or else the second quad that I suggested, 17, 21, 1 and 5. In that case, these two and these two will form quad, but again, you will be left out with these two, that positions 13 and 23. So these will be left out. So that will not be a very good choice. So for that case, we will just take the best case possible, that is forming a quad in a equal to 1. So this resolves addition of our these two variables 21, 23. But what about 24? So if you see for 24 in this table itself, that is for a equal to 1, there is nothing that you can form. And to check whether this forms a pair with a equal to 0 table, you will have to check the corresponding position, that is 8. So at 8 you don't have a 1. So this won't form a pair with it. So this one will be an implicant in itself. So you will have to write down its complete expression. So this one will give out its complete address. That will be a equal to 1, then b c bar d bar e bar. So this will be one addition. So if we try to write down the final minimized function for this modified problem, where we have taken the quad in a equal to 1, because that is giving out its to be its minimized this minimized form. So there we can always write down the previous quads that we formed. So in a equal to 0, we had formed a quad in 4, 5, 12, 13. That was having form a bar, c, and here d bar. Plus, you were having this green colored one, that was a bar, c, and e bar. Then you have a new quad because of addition of these terms. Now that quad lies in the table of a equal to 1. So there a doesn't change for that quad. A remains as a. And in this quad, b doesn't change and e doesn't change. So b bar and e, that remains. And then you have the pairs. So these pairs were part of the problem that we solved earlier. So they remain as same because you don't need to form a new pair or quad to include any new ones that we have added. So those will be again same, A bar, B bar, C bar, and E, plus the vertical one, that is A bar, C bar, D, E. Okay, and then there was one left out, that was in table A equal to 1. Now this one could not be adjusted in any pair, quad, or any other grouping. So this we have to write down as its complete form that we had earlier pointed out. A, B, C bar, D bar, E bar. So this will be your complete minimization of this five variable problem. So whatever we modified. So any doubts in this? I hope this was quite okay, clear to you guys. If there is something you
Yes,
want to
sir.
share.
Thank you. Yeah, it's clear.
Now this was just for a Venn diagram. So the Venn diagram that we earlier drew, that was for only A and B. This is for ABC. So you have to deal with three circles and be careful of the overlaps. So what we have to denote this in K-map and Venn diagram also. So for its K-map, A and BC. So 1, 2, 3, 4, 5, 6, and 7. So whatever positions you have, 0 will be having 1, 1, 4, and 5. So this will be denotion in K-map, and since it is not asked to minimize it, so that is fine. You can just draw and leave it. But if you minimize it, there A changes, you will form a quad there. A changes and C changes. So the function would remain only B bar. So and this B bar, if you try to see in this Venn diagram, so this is circle A, B, and C. So this B bar can be denoted in the form that this universal set and this complete is universal set, and you just need to define the function B bar. So whatever is excluded from the circle B, that will be included in your function. So if you try to shade it out, so excluding the circle B, whatever region is occupied by B, this will be your B bar. So F equal to B bar will be denoted like this in your Venn diagram. So I don't know whether you have faced these kind of questions or problems yet, but since the origin of K-map is related with Venn diagram, so that's why I included this one. So did professor teach about Venn diagram in the course? Okay, leave it. Now this is again like we were discussing the five variable problems, and I realized like you guys wanted to solve some five variables when I started this class. So let's solve this one also. So I think you guys should also start solving it on a piece of paper and post the photo of the solution. I don't know whether sending a pic is an option in this or not, but yeah, if you solve it, just ask me, share your screen, and you can show the solution. Meanwhile, I will solve it here. But please first request that you want to share your screen. So this is a five variable problem again in PQRST, and this is the function that we're having. So this doesn't have a don't care condition. So we'll just start solving it. So as we had did for the problem earlier, here again we need to deal with two tables. One for P equal to 0. Now this is totally your choice from what variable you want to switch to other table, but this is the most common thing to do, that just take the highest valued place value variable, that is P here, and take that as 0 and 1 in separate tables. So that is just helpful in solving, but that is totally your choice which one you need to take. So QRST, QRST, and I hope you guys also solving it parallelly, and I hope you will be solving it before me. 1, 1, 1, and 1, 0. Okay, and quickly we can write down the position, because once you define them, it's easy to write down your variables. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Continuing to the other table, 20, 20, 21, 22, 23, 26, 27, 28, 29, 30, and 31. Okay, so now let's write down the ones, and yeah, always be aware what is the form of the question. So here summation is there, so that is sum of product. You can easily get tricked if this was a position of sum. So this we had seen in last week. Even I made a mistake in that question. Some of the students are here when I did that. So just be aware of the function that you are having and that you need to solve. So this is simple SOP, so that is well and fine. But if it was a POS, you just need to take a note what function is there. You can very easily make a mistake in this. Even I did one. So here let's write down 0 to 4. Let's just use a different color. Yeah, 0 to 4, 7, 8, 10, 12, then 16, 18, 20, 23, 24, 25, 26, 27, and 28. Okay, so now we have populated our K-map according to the function that we have got. Now let's see whether is there any group of 16 here that we can form. So I don't see a group. If you guys see it, correct me later. Then we will try to see if there is a group of 8 that we can form. So we write this down that this is p equal to 0 and this is p equal to 1. Okay, so let's try to spot a group of 8. So here in this case, in 0, 1, 12, 8 and 16, 20, 28 and 24. So in this column and this column, since these are rollable, so this forms a group of 8. So I will just mark the groups with black. So this and this actually forms a group of 8. Now, is there any other group of 8 possible? So I don't see one. Now let's see group of 4s. So since these two columns are already covered, we don't need to worry about them. We need to worry about covering other ones in this K-map. So a group of 4 is clearly visible in p equal to 1 table. This can form one group of 4. And now we need to see the remaining ones, how to include them. So now no more group of 4 is possible. Yeah. So now we will form just pairs. So now, as you remember, we have already seen our selective implicants. So here, your choice can differ from mine, but the final function will be same. So they may have a different variables, but that depends on your approach, which groups you are able to spot first. So here in this case, I will just go and take pairs between p equal to 0 and 1. So here in positions 2 and 18, this forms a pair. In position 7 and 23, this forms a pair. And you can form one pair between 10 and 26, but I will just form one rolled pair between 2 and 10. So now all my ones are covered. I will try to write down their implicants. So first one was the group of 8. So in that case, P changed its value from 0 to 1. Their QR also changed its value in every case. Only ST remained as 0 and 0. So that will give S dash T dash. So this is the group of 8 that we had formed. Now coming to the group of 4, which is this group. So this group lies in the table P equal to 1. So P will be there. And their Q and R doesn't change its value, but ST changes its value from 0 to 1 while traversing through the group. So there QR will remain non-variable as 1 and 0. So that will give Q and R dash. So this will be the quad. Then we will move on to the pairs. Now, as I had taken the choice of pairs to be rolled between the tables of p equal to 0 and 1. So there the value of p changed. So in my solution for these two pairs that I had selected, they won't be having p because p changed its value. So first I'm considering the group of 2 and 18. So in 2 and 18, p changes its value, qr remains as 0 0 and st remains as 1 0. So there p is gone, q dash r dash S, and T dash. This remains. Now the other pair that is formed between 7 and 23. We will take that one. So here also the value of P changes. So P is lost in that process. Then QR remains same and ST again remains same. So that will be Q dash R and ST have value 1 1. So ST. Now one more pair was the last one that I had formed using this rolling of K-map between 2 and 10. So last pair I should also write down 723. Yeah. So the 2 and 10 in this case P remains as 0. So this lies in the same table in as in P equal to 0. So there you will get a P dash. And since you have rolled the your K map, there the value, if you see, the value of Q changes from 1 to 0, but R remains as 0 and S and T remains 1 0. So there Q is lost because it changed its value, and R you get as R dash because it was 0, and S T dash you get. So this is the final minimized function that I got. I would like to see if somebody else got a different one because this problem has a selective implicant issue.
Sir, I wanted to ask one
Sir,
question.
sir.
Sir,
One by one.
hello.
Yeah.
Yes, sir. Sir, can we take combination of 2, 10, 18, and 26?
2, 10, 18, and 26. 2,
Yes, sir.
10, 18, 26. Oh, yeah, yeah. This forms a quad. So this will be further simplified.
Yeah.
So, yeah, a good spot. So, accordingly, this will change. So, whatever this group we formed, in that case, the value of P changed from 0 to 1. So, P is not there. Then the value of R doesn't change. Q changes. And value of S and T dash. So, yeah, since this is a quad, you are getting a three variable thing. So, yeah, good spot. And Sejal, you were also asking?
Yes, sir. Sir, in P equal to 0,
Hmm.
uh, last four corner 1. Make a quad and same as in P equal to 1 also. So we can make the 8 group like this.
Yeah, correct. So yeah, this was one thing that I was looking whether you guys will spot or not. So since I have also referred to this problem from somewhere, so I knew that there is this quad. So this group of eight forms. So this will again simplify your problem a lot. So just to speed up, you have to be aware what are the simplest forms that you can form. So if you take this group of eight, in that case, your value of P changes. So that is 0, 2, 8, 10, then 16, 18, 24, and 26. If you take that, there your P changed, Q changed, R remained as 0, so R dash, and in S and T, your S changed and T remained as 0, so T dash. So when you take that quad, this will be the thing. So yeah, you have to be very careful while forming the group of 8s and 4s. If you don't form it properly, again, like you have seen, I have written down the whole solution, but this is not actually the minimized format. So as Komal and Sejal pointed out, there are groups of 8s and 4s that can be formed, and that you have to see very carefully and then form the groups. So I hope the solution of five variable K-map is clear to you people.
Yes, sir.
Yeah, Komal.
Yes, sir.
This fifth problem we have already solved, which are prime implicants and essential prime implicants in this problem. So I think it is already four. We will solve this last problem. So which are it's okay. Just you guys also solve it and let me know the number. What are the number of essential prime implicants that you can form in this? Okay, so I will solve it here. 3, 4, 5, 6, 7, 12, 14. And if the definitions are clear to you guys, I think this will be easy. So just attempt it and let me know the number of essential prime implicants. solving this together. I can be wrong also. So if you get something, just let me know, even if that is different. Okay, so I will just write down the ones. 1, 3, 1, 3, 4, 5, 6, 7, 12, and 14. Okay, so here as our approach, previous approach to K-maps, you have to see what are the largest groups that you can form. So in this problem, you can easily form two quads here that are very clearly visible. So this row, this one, and this one. So these two quads can be easily formed. After that, since K-map is rollable, this quad can also be formed. So here, when you are tackling this problem for the number of prime implicants or any other prime implicants, you have to start from a larger number of group, that is going from 16 to 8, 4 to 2 to form your implicants. So if your key map is covered using the group of 16, so that will form the prime implicant. If not, then groups of 8, then groups of 4 or groups of 2. But in this specific problem, three groups of 4 are enough to cover all your ones. So let's say that this is group 1, this horizontal one is group 2, and this rolled one is group 3. So you have three prime implicants here. So prime implicants is the all number of groups that you can form by either using 16, 8, 4 or 2 in these form. So here we got our groups done in groups of 4. So you have three prime implicants in this case. Okay, but how many are really essential ones? So that you will have to check whether some of the groups are having all the ones that are covered in some other group. So here if you see the group 1, that is this one, 1, 3, 5, 7, and group number 3, that is 6, 17, 4, and 13. They actually cover all of the ones. Okay, and the row, the group of 4 in row, that is group number 2, that is actually a redundant prime implicant. So even if you don't consider it while minimizing, you are good to go. So this is a redundant implicant. And essentially, or essential implicants, you have just two essential implicants groups. And these will definitely come into your solution. You start in any way, you will arrive at a solution which will be having these two implicants in their solution. That is group number 1 and 3. So 1 and 3 are actually, if you just write down its function, A is not changing and D is not changing. A bar D, and 3 is B is not changing and your D is not changing, B D bar. So you can just take a task on yourself and try to solve this and minimize this. I think, no, not I think, this you will definitely get in your solutions because these are essential implicants. So this you can do on your own. And I hope you guys got to learn something and also that helped in your five variable solutions in this session. And with that, I come to an end of this session.
Thank you, sir.
Yes, Sanjay.
Hello, sir.
Thank you,
Uh,
sir.
yeah, yeah.
Sir, prime means we can more time, no, sir. I mean, for we can make group of 4 and 6 repeatedly. So, is it possible?
No, I didn't get your question. Your voice got cut off in
Yeah,
between.
please show that slide so that I can.
This one.
Yes, sir.
Okay.
Sir, here we have essential implicant 2,
Hmm.
but
Yeah.
in prime we have 2, 3. so
Yeah,
that
yeah.
we can take one more, no, so like one or two, that single combination we can take like 17, 12 and 14, then
Mm-hmm.
4 and 6. Can we
Yeah,
take
yeah.
like that?
Pairs and all, right?
No, so I'm asking, can we take like that so that PI will be 5, like,
Yeah, so that's the
so
thing.
actually I'm still
So,
confused. Yeah.
yeah, so that is the thing.
Hmm.
While minimizing your function, you can form any pair or group. But if you want to decide the number of prime implicants, then you have to start
Mm-hmm.
with the groups in power of 2. So you have to first see whether you can define all your ones in group of 16. If that is possible, then that will be your prime implicant. So let's assume if all were ones, okay? If all were ones,
Mm-hmm.
then all can be covered in one group of 16, right? So in that case,
Mm-hmm.
you will be having only one prime implicant. So you can take all ones individually or you can take pair or quad, but those won't be prime implicants.
Okay, okay.
Because
So
if,
that all one can cover.
yeah, so in other case, if you are not able to cover in group of 16, then check whether you can cover all ones in group of 8s. If that is
Mm-hmm.
possible, then that will form your prime implicant. Then again, if that is not possible, then go to group of 4s. So in whatever minimum numbers you can cover your groups, that will be your number of prime implicants. So as in one
Okay.
example that we saw, where did it go? Okay, there was one problem in which we had in this kind of fashion, right? Once in which horizontal and vertical groups were forming, right? So
Mm-hmm.
there we formed everything in groups of 2, right? So those
Mm-hmm.
give the prime implicants. And we didn't get to form a quad. So that's why we need to rely on number of pairs in that case. If you are able to cover that in quads, then that would have been prime implicant. So that is the thing.
Okay. Thank you.
Yeah, so this session I am ending it now. And if you have any questions, you can write down to me. And I will check whether we are allowed to solve questions from your assignment in our sessions. Because if you have to submit them, then that would be unfair. So I will just check with that. And if we are allowed, I will solve this problem and get back to you next session. This problem was asked by Itha Pratyusha. Okay. So yeah, thanks guys for attending.